Assalamu alaikum warahmatullahi wabarakatuh. I am Ahmed Abdullah. I am from Libya. Today I'm gonna explain my paper. My paper, which is back pain classification based on ultrasound muscle image using machine learning under my supervisor, Prof Eko. Next. This is my introduction. Myofascial pain syndrome is one of the most frequent causes of persistent pain. Around 90 million individuals suffering from myofascial, and so many more suffer globally. The ultrasound image is type image that is used many medical specialized. Myofascial pain syndrome involves regional MTRP pain and transfer pain. The preliminary findings suggest that based on ultrasound image of thoracic vertebra, the normal and abnormal activity of trapezius muscle can be autonomously classified. The aim is to help people during the COVID-19 duration to be more safe and secure. Next, this is material and method. The method was designed to demonstrate that normal muscle and dysfunctional muscle have differences. The muscle layer of regular muscle look flat and parallel to the surface, whereas the muscle layer with the trigger appears to be looking towards the region of the trigger. It is possible to see these differences in ultrasound imaging. Then, ultrasound image on one patient with back discomfort was performed. We may take 200 images of right and left muscles. The subject images of the trapezius muscle were obtained and the participant with the comfortable setting art M apparent manner with the direction of the muscle vapors. The transducer head was straight during the scanning. The muscular pressure was maintained constantly so that the muscle layer was not destroyed. Next, this is my flowchart: conventional machine learning and deep learning. First, inputs ultrasound of muscle image. The conventional machine learning included handcrafted feature extraction, then a feature selection, reduction, then classify. The finally outputs classification, procedure, guidance. Then deep learning included automated feature extraction and classify. Input layer, handing layers, output layers. The output classification and precision can nice. Can. Next, result and discussion. In the first protocol, all the muscle image of all the subject are kept as training set, except for ones that are left out and using as the test set. This was done to avoid an asymmetry between the image of the same person. In the second protocol, we partition the detect into three distinctive groups. The test set consists of 15 subjects with image each. Finally, for assessing if the muscular circulator ultrasound image of the different muscle section and the same subject are correlated in some way. A third evaluation protocol that we call hold out one was incorporated. Next, all of them I got in my result, and all of them I used the software names by I used by Python. The first day you can showing this the first all of the image, the first one output of the normal and the last one output of the abnormal. Next, conclusion. A method has been created that can identify the trigger of myofascial pain syndrome. Ultrasound images were used to determine the differences between normal and abnormal muscle. The differences were noticed in the muscle layer where regular muscle with a point of trigger look flat and anomalous muscle appear to peak at the triggering point region. This detection technique by utilizing ultrasound image is more accurate science. A quantifiable result may be achieved compared to the traditional method for detecting trigger sets with physical examination. Next, the final reference, and thank you so much. Assalamu alaikum warahmatullahi wabarakatuh.